Now, in this video, we'll just summarize chapter 3, which is higher order linear equations. Now, the objective of this chapter is to find the general solution of this differential equation, ax y second plus bx y prime plus cx y equals dx. So this is the non-homogeneous equation, and we can write the corresponding linear homogeneous equation, which is ax y second plus bx y prime plus cx y equals 0. This is the homogeneous equation. Now, the general solution of the non-homogeneous equation will have the form y equals to yc plus yp, where yc is the solution of the homogeneous equation and yp is the particular solution. That means we'll have two steps. The first one is how to find yc, and after that we'll see how to get yp. For yc, we'll have two methods depending on the type of equation that we have. Okay. Now, the first method will be applicable when we have the following situation. That means first we have constant coefficients. Constant coefficients. Okay, later on we just use the abbreviation CC. Now, this is the situation ay second plus by prime plus cy equals 0. In that case, we have an auxiliary equation which is am squared plus bm plus c equals 0. And we'll have three cases when we have m1, m2 are real solutions. Then we'll find yc as c1 exponential m1x, and then we have c2 exponential m2x. When the discriminant is 0, we'll have one solution which is a real number. In that case, yc will be c1 exponential mx and c2 x exponential mx. And the third case is when we have two complex solutions. Let's say m is alpha plus minus I beta. In that case, yc will be c1 exponential alpha x cosine beta x and c2 exponential alpha x sine beta x. Okay, so this is the situation when we are dealing with constant coefficients. That's the first case. The second case will be when we are dealing with quadratic equations. For quadratic, the situation is this: we have ax squared y second plus bx y prime plus c y equals 0. Again, we'll have an auxiliary equation, but this time around it has a different shape. So am squared plus b minus a m plus c equals 0. And then solving this quadratic equation, we'll have again three cases, m1 and we have m2, which are real numbers. So yc will be c1 x power m1 plus c2 x power m2. The second case is just one real solution. So yc will be c1 x power m plus c2 x power m ln x. And when we are dealing with complex solutions, so let's say m is alpha plus minus I beta, then yc will be c1 x power alpha cosine beta ln x plus c2 x power alpha sine beta ln x. Okay, these are the two situations for constant coefficients. That means for finding YC. Now, next step is to find YP. Now we need to find YP. Particular solution. Again, we have two methods. The first one is the method of undeterminate coefficients. Okay, that will just refer as UC. This one we will apply it in the following situation. First one, constant coefficients, a1 second plus by prime plus cy equals gx. And there's restriction on gx. Gx can be a polynomial function. Gx can be cosine or sine function. Gx can be exponential function, or it can be a combination. Combination here means we have plus, minus, or multiplication of the previous functions. Okay, so if we have this situation, then how to get YP? Find YP as the general form of Gx. That means you have to write the general form of Gx. For example, if Gx is x minus 1, so this is a polynomial of degree 1, then Yp should be written as ax plus b, and then you have to substitute to differentiate, substitute in the equation, compare with Gx to find the coefficients a and b. Now, for undetermined coefficients, there are two things to have in mind. The first one is called the superposition. If G is G1 plus G2, where G1 and G2 are two different types, two categories, so let's say polynomial plus an exponential, then in that case we can find Yp as Yp1 plus Yp2, where Yp1 and Yp2 will be obtained exactly the same way. That means differentiate in the substitute in the equation and compare with G1 and G2 respectively. But the most important in this part is actually the duplication. So if the general form of Gx is present in Yc, then it has to be multiplied with x. This is to remove the duplication. And we have to continue this process as long as the duplication is there. So we'll come back to this later to an example. Now, the second method for finding Yp is the method of variation of parameters. So variation of parameters that will use the abbreviations VP. Now the situation is the following: we have ax y second plus bx y prime plus cx y equals dx. This time around, there's no restriction on dx, and a, b, and c are not necessarily constant. We just suppose that we can find yc, which will be c1 y1 plus c2 y2. Now, the idea of this method is just to find yp in this form, where now c1 and c2 are replaced with functions. So yp, you have to find it as u1x y1 plus u2x y2. And then what we need to do is to differentiate, substitute in the equation, compare with dx to find the solutions, the functions u1 and u2. When we do this, we'll have two steps. The first one is to get the standard form. The standard form of the equation is y second plus px y prime plus qx y equals fx. This is by dividing with ax the whole equation. Okay. The next step is to find the Wronskian. We just use w to write it. The Wronskian of y1, y2. So by definition, is y1, y2, y prime 1, and y prime 2. Obtain the Wronskian. Then for this method, we all have this formula. U prime 1 will be minus y2 fx over the Wronskian, and u prime 2 will be y1 fx over the Wronskian. So this can be done for any type of function in the right side, for any gx. Once you obtain u prime 1, u prime 2, we just need to integrate to find u1, u2, and then we have our yp. So these are the two methods for finding yp. Now let's see two examples. Okay, the first one, let's say you are solving the following equation: y second minus y prime minus y prime minus 2y equals 3 exponential minus x minus 10 cosine x. So here we have a constant coefficients, and then here we have a combination of two different types. Now we have to start with yc. The actual equation, since we are dealing with constant coefficients, is just m squared minus m and then minus 2. If you go to the discriminant, it will be 1, 9, 1 plus 8. So m1, let's say, is minus 1, and m2 will be 2. Then yc is c1 exponential minus x plus c2 exponential 2x. Then next is to find yp, but since we have two different types, we'll find yp1 and yp2. So we say that u1x is 3 exponential minus x. The general form will be a constant a times exponential minus x. But constant times exponential minus x, we have it in yc. So that means that's a duplication. So we need to multiply it with x. So we have to write yp1 as ax exponential minus x. And now there is no duplication, so we can start differentiating and then set in the equation to find the coefficient a. So y prime p1, we keep the a outside. We differentiate x, we obtain 1, so exponential minus x. and then minus x exponential minus x, which is a 1 minus x exponential minus x. We differentiate again, y second p1. Differentiate 1 minus x, it will be minus exponential minus x, and then minus 1 minus x exponential minus x. At the end we obtain x minus 2, x minus 2 exponential minus x. So we just need to substitute in the equation and then compare with g1x to find the coefficient. Now when we substitute in the equation, what we obtain is a x minus 2 exponential minus x, and then we have minus a 1 minus x exponential minus x, and minus 2a x exponential minus x, which has to be 3 exponential minus x. Now the coefficient of x will have a, then plus a to a minus 2a to be 0. In terms of the constant term, you have minus 2a and minus a, so minus 3a should be 3. Minus 3a equals 3. That means a is negative 1. So we have yp1 as negative x exponential minus x. And then we go for g2x, which is negative 10x, negative 10 cosine x. Now this means yp2 should be a constant, let's say b cosine x, and then c sine x. Since a cosine might come from cosine or sine, we always have to combine cosine and sine when we are dealing with either cosine or sine. Now there's no application for this case, so we just differentiate. Y prime p2 will be minus b sine x plus c cos x. We differentiate again, y second p2 will be minus b cos x, and then minus c sine x. Then we have to substitute in the equation and compare the coefficients. Substitute in the equation, we have minus b cosine x, and then minus c sine x. That's for y second. It should be then minus y prime, so it becomes plus b sine x and minus c cos x, and minus 2b cosine x minus 2c sine x, and this has to be g2x, which is negative 10 cos x. So we just need to compare the coefficients for cosine and for sine. For cosine you obtain minus 3b minus c, it has to be minus 10. And for sine, we obtain b minus 3c, which has to be 0 because there is no sign in the right side. So from here, we obtain that b is 3c. And if we replace b with 3c, obtain minus 9c minus c, so minus 10c is minus 10. So finally, b is 3 and c is 1. Then we write yc, yp2 obtain 3 cosine x plus sine x. So yp at the end is yp1 plus yp2, which is negative x e minus x plus 3 cosine x plus sine x. Okay. Now, let's see another example. For example 2, we have x squared y second minus x y prime plus y equals x ln x. Now, this time around we are dealing with Cauchy-Euler, so the auxiliary equation will have the form m squared minus 1, that means minus 2m plus 1 equals 0. So which means m should be 1, and you obtain y1 is x power m1, and then y2 is x ln x. Now, if we're going to the next step, we need to find, because this time around we have to use the variation of parameters. We go for the standard form. We have y second minus 1 over x y prime plus 1 over x squared y equals ln x over x. So this is our fx. Okay, have to be careful for this. Fx is ln x over x, not x ln x. Then we have to go for the Gaussian. The first row is the function. We have set the function, so x and x ln x. Then we differentiate. Here we have 1, and here will be ln x plus 1. But then we do the cross product, we just obtain x. Now, u prime 1 is minus y2, so minus x ln x times fx, which is ln x over x, divided with the Gaussian, which is x, which will be negative ln square x over x. So the next step is just to integrate this function. So u prime 1 minus ln square x over x. So u1 will be minus the integral of ln square x over x dx. Now we can just use a substitution. Let's say t is ln x, dt will be dx over x. So u1 is minus integral of t squared dt. Squared dt, which is minus t cubed over 3. That means negative 1 over 3 ln cube x. So we just take the constant to be 0, the constant of integration. Now u prime 2 is y1, which is x times fx which is ln x over x. We have to go with the Wronskian, which is x. So we obtain ln x over x. With the same substitution, we'll obtain u2, which is 1 over 2 ln square x. So finally, yp is u1, which is negative 1 over 3 ln cube x, which is multiplied with y1 x, and then u2 is 1 over 2 ln square x times y2, which is x ln x. So it should be 1 over 2 minus 1 over 3, so 1 over 6 x ln cube x. And finally, y is yc plus yp. Yc was c1 x, and then c2 x ln x, and finally 1 over 6 x ln cube x. And just how to apply the method of operation of parameters.